Okay, today we're going to talk more about, I'm trying to move the little white dot out of the way. We're going to talk more about rigid motions, but we're actually using those rigid motions to prove that things are congruent. So on page 30, yes, 30 of your notebook, I'm going to go ahead and label it 3.2, proving figures are congruent using rigid motion. Okay, and we're going to label 31 that as well, and we will get to 31 today. This is only a one-day lesson. And I know that's a long title, but okay. So proving figures are congruent using rigid motions. We're going to do more proving before long. Okay, two plane figures. That means anything like a square or a rectangle or a triangle, anything that's a 2D figure. Two plane figures are congruent if and only if one can be obtained by a sequence of rigid motions. We just talked about sequences of transformations, but now we're talking about specifically about sequences of rigid motions. Remember, rigid motions are translation, reflection, and or a rotation, and it could be any of those. Today we're going to have to identify if one of these happened or not. All right, in order to do that, we're going to rip some pages out of your book. So get your book out. Okay, you are going to tear out of your book page 128. You don't have to write this. Remember, I'm just writing it so you, in case you missed it. 128, 129, and that's it. 128, 129. From 128, you're going to cut out numbers 2 and 3. Do not get rid of any of the papers until I tell you to do so today. We're going to wait and kind of cut them out as we go because we're going to work the problems first. So 2 and 3 from 128, and we'll get the others later. Go ahead and glue 2 and 3 right there. Unless I specifically say don't, you will always cut out the directions with it. Okay, 2 and 3. Use the definition of congruence to decide whether the two figures are congruent and explain your answer. Here's the definition of congruence. Two plane figures are congruent if and only if one can be attained by a sequence of rigid motions. So we have to decide if there's a sequence of rigid motions. Is there a way, and we're going to go from the beginning of the alphabet to the end, is there a way to get from A, B, C, D to W, X, Y, and Z? That's what we have to figure out. To me, it looks like there is a way. It looks like we can actually do it in one step. I'm thinking that it looks like it is a reflection across the x-axis. So I'm thinking it's that x comma y maps to x comma negative y. Now I didn't ask for the rule, so that's not the answer, but that's what it looks like happened. So to explain, you can map A, B, C, D onto A, B, C, D, W, X, Y, Z. We have to match them up. W, X, Y, Z with a reflection across the x-axis, which means so A, B, C, D is congruent to, that's the first time we've used this in where we actually had to write it ourselves. This means it's congruent to, let me move it down so you can actually see it. This is congruent to W, X, Y, Z. There is my explanation. I didn't need this, but I put it. Okay, pause the video and try number 3. See if you can get JKL onto XYZ. There's more than one way. Yours does not have to be the way I'm going to say it is in a minute. Okay, here's what I'm thinking. I'm thinking we could take JKL and reflect it over the y-axis, which is negative x comma y. But then, to get it over here, I would have to move it over. 1, 2, 3. But it's not 3. This is counting by 2's. So it would be over 6. So x minus 6, but the y stays the same. That's what I'm thinking we could do. Of course, we could do something else. So we can do it, though. So you can map JKL, and we need to put a little triangle symbol, onto triangle XYZ with a reflection and a translation. I gotta move it so you can see it. And I'm telling you I'm moving it, and then it froze. So we're gonna have to go out of full screen for a second. There we go. With a reflection and a translation. So triangle JKL is congruent to triangle XYZ. There we go. Trying to see if they are congruent or are not. All right, we are cutting 5 and 8 from page 129. We're still not done cutting, so don't get rid of these papers unless you want to be handwriting something or printing something else off. Don't get rid of them. 5 and 6 and the instructions for 5 and 6. Here's 5 and 6. So glue those in right there. All right, so the figures are shown. The figures shown are congruent. So we already know they're congruent. That means we don't have to actually say this now. We already know they are. Find a sequence of rigid motions that maps one figure to the other. Give coordinate notation for the transformations you use. Okay, we are no longer doing this. All it wants us to do is give the coordinate notation. That's the same as the rule. So coordinate notation is the rule. Okay, that's what we are doing. So we don't have to do anything but give the rule. So number 5, we are going from JKLM to WXYZ. I know I'm going to start with x comma y, and I'm going to do something else. There are multiple answers for each of these. That's true on your homework as well, which means if you pause this and try one of these on your own, when you press play again, it doesn't mean that what I have is the only answer. If you want to ask me if your answer is correct, ask me. All right, x comma y maps to, trying to get J and W to line up, because look, J and W, they line up in the words, they should line up in the picture. I'm thinking I'm going to reflect first, so I'm going to put J right here. So a reflection across the x-axis is x comma negative y. If you need to help yourself, you could write down J's point and then write it down under this and then write it down again just to make sure it gets to W. Because now it looks like I need to shift to the left and shift down. This one is counting by twos again, so pay attention to that. So to get right here, I'm going to go over 4 because it's counting by 2. So that's minus 4. And I'm going to go down 1 unit, which is actually 2 because it's counting by 2. So y minus 2. And that should put J and W on top of each other right there. So if I need to check, though, I could write the points down. This is 2, 4, 6, comma 2. Okay, and then I'm thinking, well, I reflected it, and it should be right here. Okay, so that changes it to 6 comma negative 2. That's right. Okay, but I still need it to be at 2 negative 4. So does subtracting 4 get me to 2? Yes. Does subtracting 2 negative 2 minus 2? It's negative 4. So I did it right. That is actually, you can either call it J double prime, or it's actually W, and it is W, so I'm good to go. This, though, is the answer. This is all you have to have written down. That's all it asks for. Pause the video and try number 6 on your own. Remember, when I start giving you the answer, it does not mean yours is wrong. All right, number 6. Let's just pick a point. Let's pick A. I always find that the easiest. Let's pick the first one, and it should eventually match up to P. Well, it's A and P. I got to get over here somehow, so I'm probably going to flip it across the y-axis. And to flip across the y, I have negative x comma y. I'm going to graph A. It should be here now. A prime. I got to get it to P. Well, to get it to P, it looks like I'm just going to go down. Count by twos again. 2, 4, 6, 8, 10. A will then be on top of P. So the x's don't change. It's still x. The y's change to y minus 10. You might have had a different one. That is okay. As long as you get this point to this point, you're fine. The reason I only have to check one point on these is because it says they are already congruent. If they were not already congruent, I would actually need to check all points to make sure they got there. Because if it's a dilation, they're not congruent. Or a horizontal stretch or a vertical stretch, they're not congruent. All right, last piece that we're going to cut out and do. This is from page 129. It's actually the back. It's 130. From 130, you need example A and B and number 7. So almost that whole rest of that page there. And we're going to glue it to page 31. So I'm going to show you. We're going to glue it in. This is the back, page 130 here. You need the whole thing. Glue it to 31. Okay, you're going to need a straight edge for this because some of these, the angles, we will have to extend to actually see whether they are congruent or not. We could take our ruler, our protractor, and actually measure the angles to determine if these angles are congruent. But I'm going to show you how we can actually do it without a protractor, because they won't let you have a protractor on the test. But you can have a straight edge, I think. I'm pretty sure you can. Okay, so I got my straight edge, not using it as a protractor, I'm using it as a straight edge. I've got right here. I want you to notice, I'm going to look right here, and I want all of my flat lines here to go all the way to 2 units here. And this one does. It's 2 units. This one doesn't, so we're going to extend it until it does, because the direction is not going to matter on the angle. Okay. I got 2. Now this, we're going to count slope. This goes up 1, 2, 3, and over 2. So I've got a length of 2 and a slope of 3 over 2. Okay. I got a length of 2, but I got a slope of up 1, over 1, up 1, over 1. I got a slope of 1 over 1. B is not congruent to A because the slopes are not the same. Okay, C. I got a bottom here 2. I got up 2 over like a half. Let's extend it so it actually crosses one of these points so we can actually count. So I'm just extending it. You can extend things. That's not going to hurt anything. Okay, now it crosses right here. So up 1, 2, 3 over 2. Hey, these have the same slope. That means if I measured them, and I will because I might need to measure them too. If I measure, so to measure angles, I take, you see this little point right here? You either have a hole there or a 90-degree angle. I take this, I line it up, and then I line it up here. It looks like it's 60 degrees. It's close to 60 degrees. Okay, and then I do the same here. It's not exactly 60, but see how it's a little close? It's close to 60 degrees. Okay, and then this one, oh no, it's closer to 50. So A and C are congruent as it says. Let's try lines now. We're going to count slope again. So A to B, I'm going to go in alphabetical order, is -3 to 2. Technically, I'm using the distance formula. Remember when I used the Pythagorean theorem as the distance formula? So I'd have -3 squared plus 2 squared. But as long as the slopes are the same, not the slopes, as long as they have the same numbers here and here, then they are congruent. This goes up 2 and over 1, 2, 3, 4. These are not congruent. It's not a 3 and a 2. Doesn't matter if it's positive or negative. D to C, up 3, over 2. Okay, these are the same because while it's not negative and positive, because when I plugged it in, if I plug it into this, because I'm squaring it, it would be the same. So what that means is AB and DC are congruent. A sequence of transformations is they have to translate, but they also have to reflect. There is no transformation that maps EF to any of these. See if you can see if number 7, if any of those are congruent to each other. You can either measure or count slopes. Let's start with segments. You should pause. You should figure it out. I'm going to keep going. Okay, let's go ahead and get all of these going on here. Ooh, I hate how this one's in the middle, but oh well. Down 3, over 1, 2, 3, 4.5. Down 2, over 1, 2, 3, 4. Up 2, over 1, 2, 3, 4. Oh, GH is congruent to CD. E up to over 1, 2, 3, 4, 5. These two are the only ones that are congruent. That's the only thing that's congruent for my segments. And it looks like I would just need to reflect and translate. Okay, that's the segment. Now let's do the angles. This one's going to be hard to actually count the slope, so we're actually going to measure. Okay, gotta line it up. Here's my angle. It points exactly to 80. Okay. I'm going to turn my paper to be able to do the next one. You can't see me when I turn it. That'll be okay for a few minutes. Alright, so I'm turning it so that I can put this down here. Okay. Oh, look. See, it points right to 80. I'm going to do it for this one. Oh, that one's 90. I'm back. Okay, so it looks like B and C are congruent. So angle B is congruent to angle C. And let me see, how do we get B to C? We're going to have to reflect and translate again. Most of them are that on these. All right, today you're going to finish homework over proving figures are congruent using rigid transformations. I will post the answers like I've told you about for the homework. One thing about this is just because the answer I give you is what I give you, it does not mean it's the only possible answer. I will see you later.